Okay, we'll do another Trig 1 test. Question 1. Use the unit circle below to determine each of the following values. Now guys, we should know that in a unit circle, everyone should know this, that always, if I was to draw this, so let's say this is your axis and this is your unit circle, we should all know that all angles are always measured clockwise from this way. They're always measured anti-clockwise from the positive x-axis, and they'll always have a corresponding x and a y value. We should all know that the sine of the angle is always the y value. Cos of the angle is always the x value. And the tan of the angle is always is sine theta divided by cos theta, which means it is always the y value divided by the x value. So that's the basics that we should know about unit circle. We can use a unit circle. We can use a circle of radius 1 to help us find the sine and cos of any angle as long as the angle is anti-clockwise from the positive x-axis. So the first one, cos 56. So we just have to go 56 this way. And when you go 56 this way, it gives us this angle here. It hits the circle at this coordinate. And cos is the x value. So the answer is simply cos 56 is C. Alright, it is the x value there, which is C. Next one, sine 156. Now that's interesting because this 156 is quite a way through. So 156 is like here somewhere. Now, what you're meant to do is notice that there is some sort of symmetry. If you do 156, guys, 156 is somewhere around about here. But what you're meant to realize that if this here is 156, then as per symmetry, because angles in a straight line add up to 180, that would make this here 24 degrees. So what you realize that, hey, if that's 24 degrees, it's completely symmetrical with this, which means that where would this hit the circle? Well, it hits it at the same y value as this. The only thing difference is the x value. So basically this point here is negative a and still positive b. And we want the sine value. And remember guys, sine is always the y value. So what's the y value it hits at? B. That's one way of doing it. I'm pretty sure some students would have preferred to do this. They would have preferred to say that sine 156 degrees. That means that we are going all the way here. That means the reference angle is 24 degrees. And what is sine in that quadrant? We should all by now know that all of them are positive here. Only sine positive, only tan positive, and only cos positive. So a lot of people would have just realized that, okay, we don't need to do sine of 156. We can just do sine of 24 and realize that the reference angle is 24 degrees and that sine is positive in that quadrant. Okay? And that would have given them B as well. And lucky last, tan 336. So why don't we do it using our reference formula way? So where is 336, guys? 336, if I was to draw it completely separately, 336 is like an actual angle of this. It is an actual angle of all the way here, which is 336 degrees, which means the reference angle is that, which is 24 degrees. So tan 336 means the reference angle is 24 degrees. And what is tan in this quadrant? Remember, it's all positive, sine positive, tan positive, cos positive. So it is negative in this quadrant. So it is negative tan 24. And we just discussed how you find tan. Tan is sine of 24 divided by cos of 24. Now, we can use the unit circle to help us work out sine of 24 degrees. Sine of 24 degrees is the y value at 24 degrees. The y value there is b, and the x value there is a. So this would be sine 24 is b, whereas cos 24 is a, and therefore your answer is minus b on a. Perfect. Next question. Convert your angle, it's calc-free, convert your angle from 135 degrees to radians. We all should know that to go from degrees to radians, you have to multiply by pi on 180. So all I have to do is do 135 times pi on 180, and that's quite convenient, guys, because 135 on 180, you can actually simplify that to 3/4. So that is 3 pi on 4. All right, next question is the other way around. They want you to go from radians to degrees. And we know that if you want to go from radians to degrees, you don't times by pi on 180, you divide by pi on 180, aka times by 180 on pi. So without a calculator, I need to do 7 pi on 6 times 180 divided by pi. All right, pi just crosses out. 6 and 180 becomes 30, and 30 times 7 is 210 degrees. So 210 degrees. Next, evaluate sine 60 and tan 30. We need to know our exact values. Sine 60 is root 3 on 2, and tan 30, I usually write root 3 on 3. I usually write, guys, tan 30 is root 3 on 3 because it's rational, but I specifically wrote 1 on root 3 because I realized that by writing 1 on root 3, the root 3's will cross out. So the answer you're left with is half. Okay? The ones that you need to know, guys, that have multiple values or like multiple ways of writing it is, for example, sine 45 or cos 45. The rational way of writing sine 45 or cos 45 is root 2 on 2, but be aware that it can be written as 1 on root 2. The other one is the one that we just discussed, the tan 30. Yes, the rational version is root 3 on 3, but it can also be written as 1 on root 3. So please be aware that these are the ones where you can express it in like multiple different ways, one with a rational denominator, one without a rational denominator, okay? All right, cos 2 pi on 3. You either do it in, look, there are two ways to do it. It's your choice. So students that are not so strong will have to first convert the 2 pi and 3 into degrees. So they'll have to do 2 pi and 3, and they'll have to do times by 180 on pi, and that gives us pi and pi crosses out. 180 on 360, that gives you 120 degrees. So a student that is not strong will first convert that to 120, and then what they'll do, once they've converted it to 120, what they are now able to do is realize that, okay, that means that the actual angle is 120. And if is that what I did before? Yep, the actual angle is 120. And if the actual angle is 120, it means the reference angle is 60. So then they'll be writing cos 60. Then they'll remember ASTC. Only sine is positive here, but this says cos. So therefore they'll put a negative in front of it, and then knowing your exact values, that's neg half. So that's how a weaker student would do it. They would first convert it to degrees. If your intention is to do year 12 methods, we need to be comfortable with radians straight away. Someone comfortable with radians straight away realize that, okay, that's 0, and that's 0 radians, and that's pi radians. So 2 pi on 3 means 2/3 of the way. 2 pi on 3 means 2/3 of the way, so that's 2 pi on 3, which means this is 1/3 of the way back, which is pi on 3. So a strong student doesn't need to do that. A strong student can immediately just do cos 2 pi on 3. They realize the reference angle is pi on 3, yet negative, and they're immediately able to write negative half. Okay, so up to you how quickly you get used to radians, but that's the two ways the question could have been done. Next question. A circular pizza is cut into 12 equal pieces. All right, 12 equal pieces. All right, so guys, if it's cut into 12 equal pieces, what is the angle subtended at the center for each of them? Remember, we don't do 360, we do 2 pi. You should all remember that. We're no longer doing 360 degrees. We're going to do stuff in radians, which is 2 pi. So theta is 2 pi divided by 12. So each angle is pi on 6 radians. And guys, what are the three formulas that we need to know if angles are in radians? The three formulas that we need to know that if the angle is radians is length of an arc is r theta. Area of a segment is half r squared theta. And area of a, sorry, that's not segment, that's a sector. This is the formula for area of a sector. And area of a segment is half r squared bracket theta take sine theta. There is another formula that you can use. The other formula is special because for these three, the angle must be in radians. Theta must be in radians. However, the formula for length of a chord does not require the angle to be in radians. The formula for length of a chord is 2 sine 2r sine theta on 2. Okay, the angle does not have to be in radians. This one, theta, is either radians or degrees. Radians or degrees. I hope everyone knows where that formula for length of a chord came from. So if you think about it, there's your chord. And we want to know how long it is. Now, if I was to connect it from here to here, I hope everyone realizes that I've created an isosceles triangle because that's the two radiuses of a circle. All right, and we've obviously cut this angle in half. So if this angle used to be theta, but if I cut it in half, each bit of the angle is just theta on 2. And we can realize that's cut in half, so it's 90 degrees. And then we can call this A. Remember, A is half the chord. So what we can do is write sine theta on 2 equals opposite over hypotenuse. A is r sine theta on 2, which means the length of the chord is 2a, which is 2r sine theta on 2. That is a proof behind the length of the chord formula. Anyway, back to this. We now know that each angle is pi and 6 radians because an entire 2 pi was split into 12 pieces. And we just discussed that the formula for length of a chord is r theta. So it says the arc length of each pizza is 4, the radius is unknown, and the angle is obviously pi on 6. We just have to bring pi on 6 to the other side, so r is just 4 times 6 on pi. So the exact radius, guys, is 24 on pi centimeters. That is the exact radius of the circle. Easy. Alrighty. Next question. Write down the value of the gradient. Now, guys, we really should know that the formula for the gradient of a line is tan theta. Except theta, guys, is the anti-clockwise angle made with the x-axis. The anti-clockwise angle between the x-axis and the line. So what I'm trying to say is if you want to find out the gradient of this line, obviously, guys, there are other formulas for gradient. Rise over run, aka y2 take y1 on x2 take x1 is another formula. But in terms of angles, that is a formula. So if I wanted to find the gradient of this line, guys, I need this angle right here. All right, I need that angle right there, not this one here. So what would this angle here be? It would be 180 if you're going to do it in degrees, or if you're going to do it in radians, pi. This angle here is pi take theta because angles in a straight line add up to pi, and then that's pi take theta. So the value of the gradient here is quite simply tan pi take theta. Okay, tan pi take theta. I'll also accept anybody that wrote, if anybody wrote tan of 180 degrees, you have to write the degree sign. I'll accept that. And I'll also accept, guys, there are a few kids that would have actually done something interesting. They would have actually done, and not everybody knows this, but I'm just going to write it on the side. So tan of 180, I'll just do it in a different color because very few kids would have done this, is tan is sine over cos, right? So sine 180 take pi on cos 180 take pi. And you really should know, guys, that sine of 180 minus an angle is the exact same as sine of the angle. And cos of, I don't know why I'm writing pi in both spots. Even over here, I don't know why I wrote pi. I meant tan 180 take theta. Okay, so sine of 180 take theta is the same as sine of theta. And cos of 180 take theta is negative cos theta. So if anybody in the class wrote negative tan theta, I would have also accepted it. That would have been an equally acceptable answer. Okay, all this, or this would have been correct. And these are important identities for you to know. It's important for you to know that sine of 180, I'm just going to write down a few important identities that you should know. As a year 11 method student at this stage, identities that you should know. One of them is this one here. One of them is knowing that sine squared theta plus cos squared theta is 1. And what that just means, guys, it just means sine theta all squared plus cos theta all squared equals 1. So that's one identity you should know. The other identity you should know is that tan theta is sine theta over cos theta. Another identity that you should know, at least as a year 11 method student, are the following ones here. Sine of 90 degrees, take away an angle. And remember, guys, another way of writing 90 is pi on 2. But just to make it easy, I'll just do everything in degrees so it's easier for you to memorize it. Sine of 90 take an angle is cos theta, whereas cos of 90 take an angle is tan theta. Another one you should know, sine of 180 take theta. This is the one that we just did. Is sine theta. Cos 180 take theta is cos theta. Negative cos theta. and tan 180 take theta is negative tan theta. So these are some important identities. And a few other ones that are really handy. Sine of negative theta is sine of positive theta. Oh, sorry. Sine of negative theta is negative sine theta. Cos of negative theta is cos theta. Tan negative theta is tan theta. Great. These are some identities that you should definitely know. Okay, you can prove them using the unit circle. All these identities can be proved using the unit circle. That's not the point of this video, but at least knowing the identities you should know. That is important. So then you could have very easily, guys, if you saw tan 180 take theta, you could have straight away just said, oh, negative tan theta, without having to prove why it is that. Okay. Next question. Peter and Stephen are kayaking. From a boy, Peter is 430 meters away on a bearing of 113 degrees. He's 430 meters away on a bearing of 13 degrees. So first, let's just draw a boy in the middle somewhere. From a boy, Peter is 430 meters away on a bearing of 113. So that's somewhere over here. And this angle here. Never label the entire 113. It's just messy if you write 113. Label the acute angle it makes with one of the compass points. So 90 plus another 23 is 113 and is obviously 430 meters away from a boy. So that is where Peter is. All right, Stephen is 310 meters away on a bearing of 210. So 210 would be somewhere over here, and he is 210 meters away. Okay, 210 meters, and 210 meaning this angle here is 30. By the way, guys, if this is 23, what does it mean this is? 67 degrees. Perfect. What is the distance between Peter and Stephen? So that's very easy. We can just realize that we can just do cosine rule because we know this entire angle right here is 30 plus 67 is 97. There is nothing stopping us from doing some non-right angle trigonometry and cosine rule. So what we have, we'll call this distance x. X squared is, that shouldn't say 210, that should say 310. X squared is 310 squared plus 430 squared. By the way, I'm using cosine rule because I've got two sides and the angle in between. 430 squared, take 2 times 310 times 430 times cos of that angle, which is 97 degrees. And therefore, guys, you will get to two decimal places. X is equal to 559.90 meters. Next question. What is the bearing of Peter from Stephen? The bearing of Peter from Stephen. Okay, so we just need to draw ourselves another compass bearing so we can find the bearing of Peter from Stephen. So Peter from Stephen, guys, the angle that we are interested in is this angle right here. This is the answer. Whatever this angle here is the answer because that is the bearing from north of Peter from Stephen. We just have to work out that angle. So I think what's going to help us is to first, obviously it's going to help us if we can work out this angle right here. We'll call it phi. We can use sine rule to work that out. So what we have is sine phi divided by the opposite, which is 430, equals sine 97 divided by the opposite side, which was x, which was 559.90. Bring the 430 to the other side, and then we just have to inverse sine it. 430 sine 97 degrees divide by 559.90. That is phi. And that gives us 449.66. You could have used cosine rule again if you wanted to, guys. You could have used cosine rule. I would have been equally happy with anyone that did this. You would have done cos phi because you do know the two sides next to it. So you could have done 310 squared plus 559.90 squared. Take away the opposite side squared. So the opposite side squared was 430 squared. divide by this. Make sure you guys know both versions of cosine rule. The two versions of cosine rule is the one where you have two sides, the angle in between. That's this version right here. And the other version is when you have all three sides and you'd like to find an angle, and that's the one that I'm just doing right now. So 2 times 310 times 559.90, and you inverse cos that, and you would have also got 49.66. So just two different ways of doing that question. Now that's not the answer, guys. That is not the answer. That is just that angle. So we want the entire theta. So then we use our knowledge of z's and alternate angles. So if that's 30, guys, if that's 30, this is also 30. This here would be also 30. And then obviously we have to do 30 plus 5 to get the entire angle. So 30 plus 49.66. 30 plus 49.66 is 79.66 degrees. So therefore the bearing of Peter from Stephen is, I'll accept anyone that writes 0.79.66 degrees, or anyone that just wrote it like 0.80 true. Any of those will do. Okay, you don't have to write the T, but it's just often they do that for true bearing, but it's not necessary if you write it. Okay, perfect. Nice question. All right, question 6. Bill and Malcolm buy a plot of land. All right, calculate the area of the whole plot of land. Now we should know that that's two different triangles, one and another one. And the area of a triangle formula is half AB sine C. That is a formula for area of a triangle. So what do we have here? Do we have this side? Yes. Do we have this side? Yes. Do we have the angle in between? Yes. So the area of the first triangle is very, very easy. So I'm just going to say area is area of first triangle plus area of second triangle. First triangle is very easy. We just do half times by one side times by the other side times by sine of 79 degrees. Now it's the next one that's tricky. It's tricky because they give us all three sides, but they don't give us an angle. So it's up to us which angle we would like to work out. It really doesn't make any difference. Up to us which angle we'd like to work out. Okay, I'm just going to call, hypothetically, I'll call this one here my theta. Okay, it doesn't matter. Any of them, just had to call theta. Okay, so we can use cosine rule to work out theta. Cos theta equals one side squared plus the other one next to it squared. Take away the opposite side squared. Divide by 2 times 75 times 70. That gives us, once you inverse cos that, an angle of 51.63 degrees. That makes the question very, very easy. So now all I have to do is half this, and sine of this angle here. So half times half times 75 times 70 times sine 51.63 degrees. And then we just add those two up. Okay. Total area, guys, of the land is, if you want the work, I do it all in one shot in my calculator on my scientific, but that's 1042.488 and the other one's 2050.44. Adds up to, guys, to the nearest. So first of all, it's 3092.93 meters squared, but it wants to the nearest meter, so 3093 meters squared. Great. Next question. Consider this diagram below. Find, to the nearest meter, the length of BD. They want the length of BD. Okay, so that's not too difficult, guys. So first, we can use this triangle here. And you got to realize that if that's 65, it means this here is 180. Take that, which is 100 and... that there would be... 180 take 65, which is 115, and that's perfect, because if that's 115, we're able to work out that angle there. That angle there is 180 take 38 take 115. So 180 take 138 take 115 should give you 27 degrees. Perfect. Now what do we have? We technically have an angle and the opposite side. As long as you have angle an opposite side, then you can use sine rule. And remember, we're trying to find out the length of BD. So BD, again, for those that can't visualize, so first of all, there's AB, and that's the angle opposite AB. That's going to help us. That is the angle that is opposite AB, and we have technically got, we don't want this side, we want the side BD. And if you want the side BD, you will need the angle that is opposite this side. And the angle that's opposite this side is your 38 degrees. Okay, it's 38 degrees that is opposite that. So that is the rule that we're going to have to use, sine rule. So we're going to write down sine 38 divide by the, in fact, I like to keep my unknown. I like to keep my unknowns on the top. So the unknown is the length BD, right? Doesn't matter which way you write it, but I prefer to keep the unknown on the top. So in this case, the side length is unknown, so I'm keeping BD on the top. So BD divided by sine 38 degrees is equal to 28 on the sine of the angle opposite that, which is sine of 27 degrees. Okay, then we just have to bring the sine 38 to the other side and put that straight into your calculator. Make sure you're able to swap between degrees and radians appropriately so you don't get the wrong answer. So 28 sine 38 on sine, and they want to the nearest meter. Okay, I'm just going to work it out exactly and then round it. 28 sine 38 divided by sine 27. Make sure I'm in degrees. Yes. All right, so 28 sine 38 divide by sine 27. 37.97. 37.97, and 37.97 to the nearest meter is 38 meters. Okay, that is BD. Find the length CD. That's so easy, guys. You can just do normal SOHCAHTOA. You can do right angle trigonometry to find out CD. So we have, we can just go, because we have the hypotenuse now, and we want the opposite side, so we can just do sine. Sine 65 is just CD on BD, which we worked out. We'll use the exact value of 37.97. We don't want to have any rounding error. So CD is simply 37.97 sine 65. All right. And we don't even use 37.97 exactly. We don't use the rounded value of 37.97. So we just go and write times sine 65 straight onto our calculator. Times sine 65. And that gives us 34.41. And again, to the nearest meter, 34.41 is just 34 meters. Very, very easy question. Next one. AP and BP each are 12 centimeters long, and they're tangents to the circle. Okay. Show that angle BCA is 134.8 degrees. BCA. All right, well, the easiest thing to do, guys, is this. Just break it down the middle, and you got to realize that if something's tangent, it means it creates a 90 degrees. So that's so easy to work out this angle because, again, you have a right angle triangle with two of the sides given. You have a right angle triangle with two of the sides given. So tan theta equals opposite over hypotenuse. Theta is inverse tan 12 on 5, but we don't want theta. We want angle BCA, and BCA is 2 theta. Angle BCA is 2 theta, which is 2 inverse tan 12 on 5. Okay, and we just go 2 inverse tan 12 on 5. And we get 134.76. All right, I'm writing that extra decimal place just so teachers know I haven't cheated. So therefore 134.8, which is what they're saying, to one decimal place. Easy. That part was straightforward. Next part, find the area of the shaded region. So if you think about it, guys, what is this shaded region? So I would like to think the area of the shaded region is, to me, it is equal to the area of this triangle, well, basically the area of two triangles that are identical. So it is equal to area of 2 times by area of a triangle. Area of the shaded region is 2 times by the area of the triangle, minus away this sector BCA, minus away area of the sector BCA. Alright, so the formula for area of a triangle. Now I know I usually do half AB sine C, but because it's a right angle triangle, I can actually just do half base times height. So it's 2 times half base times height, and we should all know the formula for area of a sector, but we need it in radians. Formula for a sector when it's in radians is half r squared theta. The 2 and the half cross out, so what's the base? 12. The height 5. The radius of this circle is also 5. And now make sure the angle is in radians. So 134.76, use the exact value. And to get it into radians, we have to times it by pi on 180. That should give us easily the shaded area. So that shaded area equals 30 point, what does it want it to 1 decimal place. So I'll just do it exact first. So we have 60, take 25 on 2 times 134.76 times pi on 180. So 60 take 12.5, take 12.5 times by whatever this angle here was, but that's in degrees. We times that by pi on 180. And that gives us 30.599, basically 30.60, okay? So 30.60. However, they only want it to 1 decimal place, so that would be 30.6 centimeters squared. Easy question. Okay. All right, PC is extended. Find the area of the shaded region now. Okay, well that still can't be too bad. Okay, find the area of the shaded region. Now if we think about it, guys, if this was, we'd call this theta, hadn't we? We'd call that theta. So if we'd call this theta, guys, that meant that this angle here was 180 take theta. All right, now what I want everyone to realize is, what do we technically have? If you think about it, what we technically have is a segment. Is this not just a segment? Yep, that is definitely a segment. It's a segment of this circle, and what is the angle that it creates? 180 take theta is the angle that it creates. So, and we have how many of those segments? We have 2 of those segments. So effectively, the area of the shaded region this time, the area of the red shaded region this side, is just 2 area of segments, and the formula for area of a segment is the formula for area of a segment is half r squared theta take sine theta. All right, except in this particular, well, let's just be very simple. The 2 and the half cross out, so it's r squared, and be very, very careful. Theta in radians. Now, what do we have? By the way, guys, I just hope everyone realized that I know I wrote half r squared theta in the previous question, but remember, it was actually technically the entire angle here. So I know half r squared theta is the generic formula, but I should have really written half r squared 2 theta. It's okay. When I subbed it in, when I did sub it in, I didn't sub in theta, I did sub in 2 theta. But we just need to know what the value of theta is. Inverse tan of 12 on 5. But remember, we want it in radians. So theta is inverse tan of 12 on 5. But since we want it in radians, we have to multiply that by pi on 180. And that will give it to us in radians. So if I get the inverse tan of 12 on 5, oops, and undo, inverse tan of 12 on 5, and then times it by pi on 180, that should give it to us, put the bracket here, and then times it by pi on 180, 1.176. 1.176 is the angle. Okay, so back to over here is equal to 2.5 crossed out. What is the radius? The radius of this circle is 5 still. 2.5 is already crossed out. The angle is 1.176. Take sine. Now be very, very careful. Okay. Did we do this in radians? Yes. But yet, my calculator was in the degree setting, which is fine because nowhere here have I written sine or cos. As long as you're not writing sine or cos, doesn't matter whether you're in degrees or radians. But now, I'm writing sine. And if I'm writing sine, I must be in radians. I must be in radians, so I need to change it to rad. And we want 5 theta, which is the answer. Take sine of the answer. All right, and that should give it to us 1.2646. Okay, actually, I just remembered, I forgot to square the radius, so it's 5 squared, my bad. So we want 25 times by that. So we want 25 times by theta take sine theta, and that's actually, make sure I've got all of that right, 2 sectors. No, got to be very, very careful. Guys, be very careful. Remember, we don't want theta. Again, I almost made a silly mistake. We want 180 take theta, or in fact, we don't want 180 take theta. We want pi take theta. So I almost used the wrong angle. Be very careful not to make silly mistakes like that. The angle that we want is pi take theta, not theta. So pi take theta is pi take 1.176. So let's go back over here. And we actually we don't want this angle here. That's theta. We want pi take away that. So pi take away that. This will give us the correct answer. Pi minus this. Actually, the angle is 3.12. Actually, the angle is 3.12. If I give it a bit more exact, 3.121. Okay, so we got the angle, which is inverse tan of 1215. Then we times it by the, yes, we got the actual angle. Make sure I haven't made silly mistakes this time. So I get inverse tan of 1215, and then I times it by pi on 180 to get it into rad, and then I do 180, they take away that. Now, make sure that's all correct. Pi, take inverse tan of 1215 times pi on 180, that is correct. And then we can now put it into our formula. So formula that we had is area was 2 times area of a segment, which is 2 times half r squared theta take sine theta, the 2.5 cross out. The radius of this circle was definitely 5. So we have 5 squared. The angle is definitely 3.121. And then take sine of the angle, 3.121. Take sine 3.121. That's much better, and that'll give us the area of this minor segment. Okay, so 5 squared, I'm pretty sure that everything else is correct. 5 squared is 25. Just do it properly. Should be the same answer. This, take sine of the exact same thing. Yep, 77.51 is your area. Make sense? All right, good question. Next one. Okay. The top of a vertical radius, this is a difficult one. I want everyone to pause and try and do this by themselves, okay? Pause and try to do it by yourself. From the top of a vertical tower, mast stands 35 meters above the surrounding level ground. From point A, okay, so we have a big vertical tower, and I hope everyone realizes it's 3D. So when it's 2D, you draw your compass like this. When it is 2D, you'll definitely draw your compass like this, where this is north, this is south, this is west, this is east. But when it's 3D, you have to draw your compass a bit differently. When it is 3D, you have to draw your compass like this. So that's for two-dimensional, and for three-dimensional, you have to draw it, that says west. For three-dimensional, you have to draw it like this, make this line still flat, and then like this. So what this means is this is north now, this is east, this is up, this is down, this is south, and this is west. That's how you draw it in 3-dimension. So when I draw my tower, I'm going to draw the picture relatively big. All right, so there's my tower. And whoops, we're not drawing, it's 3D, so it's like this. And it says the top of a vertical tower stands 35 meters above level ground. So there is a tower that is 35 meters above the ground. So we can write 35 meters. All right, from point A, which is on the ground and due east of the base. All right, A is due east of the base. So what we're going to do is the line here, A is somewhere here, due east of the base. And the elevation from the top of the tower from due east of the base is 50 degrees. Okay, the angle of elevation from due east of the base is 50 degrees. All right. From another point, which is 60 meters away from A. Now, 60 meters where? 60 meters is like an entire circle around A. We don't know where that specific point is. But it says from another point, C, which is 60 meters away, the bearing of the mast is 24 degrees. Alrighty. From another point, which is 60 meters away, the bearing of the mast is 24 degrees. And this is the hard part. It's this bit here that is hard, where they say that C, which is 60 meters away from A, the bearing of the base of the mast is 24. If you understand that, you are good. If you don't understand that, this question becomes difficult. So what I'm able to do is this. I realize that, okay, the bearing of the mast from this point is 24 degrees. So I'm able to realize, all right, and it will take a while, it will take some practice for you to realize it. I'm able to realize that C is somewhere here. How do I know that? Because if you think about it, if I put C here, and that's on the ground, that would make sense because that would be the bearing of the mast, because this is what M is the mast. So or mast or vertical, bearing base of the mast. Yeah, so M is fine. Okay, so what you realize that, okay, that's all on ground. So if this is all on ground, then we have a bearing of 24 degrees in order to be pointing towards the mast. It specifically says the bearing of the mast from C. Yes, the bearing of the mast from the point C is 24 degrees. Okay, from another point. Okay, so that's 24 degrees. If you understood that, the rest of this question is much easier. If you couldn't get that, then it would have been a struggle. And now you even know that the distance between C to A is 60 meters. We did say, I remember I drew a circle, I had no clue where it was. I didn't know if it's that. So it turns out the distance between here to here is 60 meters. So I can draw a line like such, connect it up, and say 60 meters. All right, and they want the angle of elevation of the top of the mast from point C. So what they actually want, guys, what they actually want is this angle. So that's 35 meters. I can put here. They want to know what is this angle here. That is the question. Find that angle of elevation. All right, I'll just do it in a different color so we can see it. We want to find out what is that angle of elevation off from the top of the mast. Okay, so once you got the picture, it's much more straightforward. But a lot of people under exam pressure or test pressure for the last question did not get the picture. Now that we've got that, look how easy it's going to be. Now, what information do I have? I got this as 35. I got this as 50. That's plenty of information to help me work out what MA is. I can do simple SOHCAHTOA to work out the value of MA. So I'll be doing tan of 50 degrees. Tan of 50 degrees is opposite, which is 35, over adjacent, which is your AM. and therefore it is very, very straightforward. AM is just 35 divided by tan 50, and 35 divided by tan 50, keep it exact, but 35 divided by tan 50 is 29.37 meters. So I now know that this distance here is 29.37 meters. All right. Now, the next thing that I need to do then is this. I also know that this is 24. So if that's 24, according to Z's, according to alternate angles, this here is also 24. And if that's 24, we know that this here is 90. So that means that we actually have this entire angle. I'll just draw the 90 properly. This angle here is 90. So that means that we know that this entire angle right here, the 24 plus the 90, gives us an entire angle of 114 degrees. All right, now there is a very important learning point here. Now here's the important learning point. A lot of kids will do this. I don't want you guys doing it. I hope you've tried this yourself. I hope you've paused and tried this yourself. But a lot of kids will be like thinking this. They'll be thinking that, okay, what do I have in this triangle right here? Let's highlight what we have. We technically have this side. We technically have that, not technically, we do have that side, and we have this angle here. So a lot of kids will be thinking that, oh, I've got an angle in the opposite side. And if I've got an angle in the opposite side, I have to use sine rule. Now remember, I'm trying to figure out this side length, because if I can figure out this side length, I'm just going to call it x for now. If I can figure out this side length, I'm winning. Okay, guys? I'm winning because if I can figure out this side length, then I can easily just do SOHCAHTOA. All right, a lot of kids will think that I've got an angle and the opposite side. So if I've got an angle in the opposite side, they'll think that I have to do sine rule. So they'll do this. They'll do sine 114 divide by the opposite side, which is 60, equals, and the only angle they're able to work out, well, they have this side. So the only other angle that they're able to work out is this angle right here. We'll call it phi, is equal to sine phi on 29.37. And then you don't have to worry about the ambiguous case because you already have an obtuse angle there. So if you work out phi will be bring the 29.37 across and then inverse sine. So inverse sine 29.37 sine 114 divided by 60. And when we inverse sine that gives us a value of 26.56. But remember, guys, we don't want phi, we want x. We want this side here. So now what the kids will do is they'll tell themselves that, okay, let's work out this angle here. Let's call it alpha. So alpha, we already have one other triangle in the triangle. We have another angle in the triangle. So alpha is just 180. Take the rest. 180, take 26.56. Take away the, so we're 180. Take 26.56. Take away 114. And that gives us an angle equal to 39.44 degrees. Okay? And then they will again use sine rule to find out the opposite side. They will again use sine rule to find out the opposite side. So they could have done this. They could have now said that the opposite side is x divided by sine 39.44 is equal to, and then 60 divided by sine 114. So a lot of students will do this. And now you start running out of test time in the test. If you start doing all these steps, you are starting to slowly run out of time. Okay, nothing wrong with what I'm doing, but I'm going to show you a much better way in a moment. So if you do that, you get x is 41.72. Now, why did I use sine rule in the first place? I used sine rule in the first place because I had an angle in the opposite side. But what else do you have? You have a calculator. You literally have a calculator, and because you have a calculator, you got to think that, okay, I technically have this angle. Let's go back to what I have. Forget all this that I did over here. You could have actually just thought of it like this. You could have actually thought of it as you could just like use solver. So think about it. You have this angle here, right? So you could have actually written this statement using cosine rule. You could have said that 60 squared equals x, which you don't know, so x squared, plus the other side, which is 29.37 squared, take 2 times x times 29.37 times cos 114. you could have actually just put that straight into solver. And you'll get two answers, one of which will be negative, I'm sure, and you'll get two possible answers. So let's see what I get. So we have, again, make sure in degrees. You need to be comfortable changing into degrees and radians and not forgetting. Forgetting is going to be very expensive if you forget to change from degrees to radians. So what we have is 60 squared equals, we had x squared plus the other side next to it squared, which had been 29.37. Take 2 times x times 29.37 times cos of that angle between them, which was 114. And then we solve. So just put a solve in front of that. Math 1, solve that. And look at that, you get two answers, only one of which is positive. And what do you notice the positive answer is? 41.72. Exactly what we said before. 41.72. How much quicker would that have been? How much more faster and efficient would that have been? Much faster and efficient. Use your class pad to maximum capacity. And now, guys, it's easy. You want to work out theta. That's super, super easy. Tan theta is opposite over the adjacent side you just worked out. Inverse tan that, and when you inverse tan that, you get 40.0 degrees. And that, guys, is the angle of elevation off the top of the mast from point C. Okay, tricky one, especially for the last question, but that's the end of that trig test. Well done.